It says it's recording. Okay. All right. Like I said just a minute ago, I'm going to do a really fast review of our introduction from yesterday because it did not record yesterday. So we're going to be working on vocabulary. We should have 2 more students come in here in a little bit. Okay, vocabulary. The 2 things, I gave you a list of vocabulary things on Friday. You should have already have those from our class or from a video. The things that I want to point out today, again, is if you see some difference, if you see these words in a word problem, product and quotient, we know that this refers to plus, this refers to minus, this refers to multiply, and this refers to divide. These are answers for these problems. But if you see these in a word problem, it will help you so much. If you know that as soon as you see the word, you're going to write some parentheses, okay? And inside the parentheses, depending on which word you see, if it says the sum of, then you're going to put the sum. If it says the product of, you're going to use parentheses and the multiplication sign. This helps so much with word problems. I wish I would have known this. Okay, and then the other things that we were talking about were less than and greater than. These words we found out, or these phrases we found out, are switch phrases. And we'll show you how we're going to use those in a minute. But we wanted to make sure also that those are not confused with is greater than and is less than.
Don't confuse it with that.
I'll finish here. Yes, and anytime you don't understand what I wrote or what I'm saying, tell me, okay? Okay, when it has the is in front of the phrase, they are completely different than this phrase. The is less than refers to the inequality sign. This is less than, is greater than. These switch phrases, less than, just refers to minus or plus. But when it says is less than, it refers to the inequality sign, okay? And we found out yesterday, people that get these inequality signs mixed up usually are trying to refer to the alligator mouth, eating the biggest number. Well, that worked just fine in grade school and junior high because you were comparing numbers together. But
What was that word you used? It refers to what?
the alligator mouth,
No, before that.
inequality.
Inequality.
Let me write it.
Yes, please.
Inequality signs. That means anything that's not an equal sign. So inequality sign could be this one, it could be this one. And we found out last week we did a worksheet where we compared 2 sides. Remember the order of operations sheet we did? And we also used not equal to. This is also an inequality sign, okay? Which inequality means not equal. So we've got less than, greater than, or not equal to. Inequality signs, and you'll see these more later. But I need to explain to you right now that when you see the is with a less than, it's not this. You need to make the distinction between the two. Everybody okay? All right. So if you have these things written down, what we're going to do is show you how the switch phrase works. And then we will take some examples from yesterday's homework. We starred some of those, right, that we're going to work today. Okay, less than or greater than. Those are our only two switch phrases. Okay, so when we work word problems, and you're going to get to see more of what I was talking about on the papers that we have to do today and the examples that we're going to work on. Whatever I was going to say left. Okay, so I'll say it later. Okay, if we say 6 is less than 11. If we say that, then what we're going to do is look, we recognize this phrase right here. So we know how to write, usually it's SIX, not 6. Okay, so we write down 6. We're going to try to write math instead of these words. Is less than refers to this sign, and so writing this phrase will look like this mathematically because it says is less than. Okay? So let's try one that's similar to this. Hi, Naaman. Let's say 4. Oh, I want to write the word because that's what you'll see. Okay, 4 less than X. Now, I think what I was going to say earlier is most of our word problems, what we're going to do is be able to chop them into little pieces, and then we will just write the math in the order that it comes in the word problem. That's what's really cool about this. If we learn the vocabulary, we'll just do it in order, except when you see less than or more than. These are the only two you have to deal with, okay? These are called switch phrases. So in the beginning, if you looked at this and you did it in order like everybody else does it, then we would say 4 less than, since it doesn't have an is, we know that this is minus, so I'm going to say minus X, okay? And that makes sense because we did it in order of the words in the word problem. But we know that this less than is a switch phrase. And when we recognize that we have a switch phrase, it says that the item that is in the front of the switch phrase and the item that's in the back of the switch phrase have to be switched, okay? So this is incorrect actually because of the switch phrase. So now we have to switch places. So we're going to say X minus 4. This is the correct answer for a switch phrase. The same thing with more than and greater than. Everybody okay with the switch phrase?
Yeah.
All right. So let's actually put these into action. This is pretty much what we went over as an introduction yesterday. Okay, first problem that we starred. Which sheet is it on and which number? Is it sheet 1-4? Is that what we were going to do?
Yeah, 4.
Okay. Sheet 1, number 4. Since you all have the paper in front of you, I'm not going to write the words out. Okay, but for the recording, I'll read it. If you-
Yesterday? Yes.
Okay.
Yeah. Yes.
Number 4. If you add 2 to me, which we found out is our variable, if you add 2 to me and divide me by 3, you get 8. What number am I? So I'm going to add 2 to me. Here's me, and I'm going to add 2 to that. Are you guys okay with that? Now, it's a little confusing the way it's written here. And divide me by 3. So this is the way you want to write it. Remember that the fraction sign in anything means divide. And so this is how we indicate the divide. You add 2 to me and divide by 3, you get 8. Now that was the first thing that was confusing to some of you. And then probably most of you, after you got it written correctly, then it was, dang, how do I do this? Okay, so those of you that just came in new yesterday probably won't have seen this at all. And I'm going to remind the older students, okay? We're going to do what we always do. We always do step number 1. I heard a little complaining yesterday about the line down through the equal sign. Not saying who it was. And step number 2 is to circle your variable. Now there are reasons for this, and I probably told you, are we about at 18 or 19 times that I told you the reason that we circle the variable, it is because that's what we want to have left when we get done with all of our math. We don't want to touch this, but we've got to get rid of the +2 and the divide by 3 so that we can have the x by itself when we get down here, okay? Also, circling the x tells us I don't focus on this side. I need to focus on this side to see what I get rid of. Sometimes later on, if you don't circle this, you're going to try to subtract 8. I've seen it, okay? So look on the side that we've circled the variable, and that's where we focus on things to get rid of. Now, here is the crux of everything. Whenever you have a problem like this, there's an x plus 2, and it's divided by 3. That means all of this is divided by 3. Not just the x divided by 3 or the 2 divided by 3, but this whole thing is divided by 2. So, or 3, sorry. So, what I've been doing, and sometimes you'll see it written this way, is since all of this needs to be divided by 3, we're going to group it into what I call a set. You'll hear me talk about a set. And it's because it's connected with a plus or minus, and all of it needs to have this done to it. So I'm going to group it together so I don't forget. And this is something you'll just have to get used to. I'll continue to tell you. Now, when you have a set, to me, it is like a locked building. I call it a barn sometimes, a warehouse. These are locked inside. That means, although you have been taught all along that we do the plus or minus, get rid of the straggler first, well, the straggler's locked in the building, and you cannot go up into this building and just grab somebody out. You can't do that. The only way that we can do this is what I call unlock the building and let these out, okay? Now, the way we're going to unlock this building is get this out of the way. This is what's locking it. If I get this out of the way, then I can just have an x plus 2 and I'm good to go. So, and also, if you come up and ask about this, and you found this out yesterday, if you come and ask about this problem, I say, okay, look at this problem. What do you not like? What do you not like? I don't like that divided by 3. Well, then let's get rid of it. And that's how I remember to get rid of the 3 first. I don't like it. Everything else would be good if that thing wasn't there. So we're going to get rid of the 3 first, and that will unlock all of this. The way that we get rid of the 3, we have to say, okay, I want to get rid of the 3. How is the 3 hooked to the rest of the problem?
Divide.
It's divide, see, right here. It's divided by 3, and how do we get rid of divide?
Opposite.
We multiply, right? So instead of coming down here and multiplying, it's a little bit confusing when we have fractions. So when we have divide like this, let's go out to the side and multiply. It's the same thing. So we said, since it's divided by 3, we're going to multiply by 3. And we're going to multiply by 3 over here because we do the same thing. There's a multiply. We do the same thing on both sides to keep the equation balanced. Okay? I put the 3 kind of up high because I knew, since this is a fraction, a numerator and a denominator, I want to make this a fraction. You can make any whole number a fraction by putting it over 1. Any number, it's fine. It's an invisible 1, but right now we need it, so we'll write it. Now, our cross-canceling, which we need some more practice on, but this is cross-canceling if you have a numerator, the top, and a denominator, the bottom. If they will divide by the same number, you can divide them both by the same number. It's called cross-canceling. So we can see that this will divide by 3 and that will divide by 3. So when I divide this by 3, I have 1 left. And when I divide this by 3, I have 1 left. Okay? Now, when I've cross-canceled everything that I can on this side, I'm only dealing with this side, then I multiply the tops and multiply the bottoms together. On top, I have 1 times this parentheses stuff. Or you can do your distributive property, 1 times everything that's in the parentheses. So now I have 1 times x is 1x plus, and 1 times 2 is 2. On the bottom, I have 1 times 1, which would be here, but we found out that we don't have to write the invisible 1 if it's on the bottom. So we're going to take that off. And now these don't have to be in the barn anymore. Okay, they had to be kept safe away from the 3, but now the 3's gone. Equals 8 times 3 is 24. And look, bam, it looks pretty easy now, right? It didn't 2 weeks ago, did it? And it looks pretty easy now. We still have the line down through the equal sign, and we still circled the variable, so we know exactly what to get rid of. It's a plus 2, so we have to minus 2 to get rid of it. We have to do the opposite operation, make sure that the numbers match, because if the numbers match and the signs are opposite, they're additive inverses. It's a 0 pair, and they cancel each other out. But we minus 2 over here, and I shouldn't have done that. I should have done the minus 2 here first so I don't forget. This zeroes out, so when I add straight down, I have an x equals, I'm adding here 24 plus a negative 2, but you can obviously see that that is also 24 minus 2, which is 22. Yes? Okay.
When I was doing it wrong, I was crossing, time crossing, and then time crossing that way. 2. So I was doing,
You were doing what?
I was timing.
Yes, you were. You were
Remember?
cross
I was
multiplying
cross multiplying.
instead of cross
instead of
canceling.
cross- Yeah.
There's a lot of confusion there too. Does this help a little bit? Okay, I'll have to continue to show you what things are sets. You'll get used to it pretty fast.
I got another one that,
Yes, we have several that are starred, so can you tell me that one now?
it's on sheet 3,
Sheet 3.
number 5.
Sheet 3, I've got to be careful when I say that. Sheet
Sheet 3.
3, number 5. If you subtract 5 from me and divide me by 8, you get 5. Okay?
3.
If you subtract 3 from me, yes, ma'am, thank you.
I'm like, wait, you're confusing me.
Again, if you subtract 3 from me and divide by 8, you get 5. What number am I? Okay, so me is the x. Here's me, and I'm going to subtract 3 from me and divide me by 8. You get 5. Now later on down, actually there's going to be another way to solve this, okay? But I'm not going to give you too many ways. I actually talked to somebody yesterday and they said, a teacher I had, they kept saying you can do it this way, or you can do it this way, or you can do it this way, and you just choose. And I kind of like to do that, but I found out it's so confusing. And she said, oh my gosh, it was horrible. I think she was a nursing student in college and it was really bothering her. So the first thing we do is put our line down through the equal sign and circle the variable. Now again, this looks very familiar, doesn't it? Because we have a set up here that the whole thing is divided by 8. Do y'all see? And so to help you out, let's make it a set. Okay? Let's make it a set. Now if you look at this, you want to get rid of the -3 and you want to get rid of the divided by 8. And usually we do get rid of the straggler first, but the straggler is locked in a set. And we have to unlock the set. This is holding it together. Okay? And again, if you just sit back and take a breath and say, yes, good, I like it. And you look at it and say, man, this would be a lot easier if I didn't have to deal with that 8. So let's get rid of the 8. Okay? It's the problem person anyway. It's locking this together. So if you say, okay, you're saying to yourself, I want to get rid of the 8. Then the next question you ask yourself is, how is the 8 hooked to the rest of the problem? How is it mathematically hooked? It's hooked by this divide sign. If I want to get rid of a divide 8, I have to do the opposite operation, which is multiply by 8. When we're dealing with fractions, let's multiply out to the side. So I'm going to multiply by 8. I'm putting it over 1 because it's a fraction. I'm just dealing with fractions, just makes it easier. And I have to balance. So as soon as I put this on one side, I need to go over to the other side and multiply by 8. I could put this over 1, but I'm not dealing with fractions. That's why I didn't. And now we look again at the side we're dealing with, and we see a numerator, the top of a fraction, and a denominator somewhere in the problem that will divide by the same number. They actually both divide by 8. So I'm going to divide this by 8 in my head, and 8 divided by 8 gives me 1, and 8 divided by 8 gives me 1. Don't try to do this if it's two bottoms or two tops. It has to be a top of a fraction with some bottom of the fraction. And then this is called cross canceling. When we get to the ones, we can just multiply straight across. 1 times x is x minus 1 times 3 is 3. It's all over 1 times 1. I'm not going to put the 1 on the bottom. Okay? Equals 40. Yay! So what do I do next?
Get rid of that 3.
Get rid of the 3. It's a minus 3, so we're going good. We're going to plus 3 and plus 3. So our answer should be x equals 43. Questions?
I think I actually got that one.
You did what?
I said, I think I actually got that one.
Good. It's good. Okay, I think there were 1 or 2 more. Were there? That we put stars on? Maybe not.
Number 6.
Number 3 on
Number 6.
sheet 3, number 6.
Yes.
Got it. Okay. This question, I'm going to read it for the recording. If you add 5 to me and multiply me by 8, you get 72. Okay. So it says, if you add 5 to me, here's me, and I'm going to add 5 to me. And multiply me by 8. Okay. If you didn't know about the set thing, then you would put multiply by 8, right? Equals 72. Yes?
Yes.
But we found out that multiplying by 8 didn't mean I'm just going to multiply the 5 by 8 or the me, x, by 8. I'm going to multiply the set by 8. Okay? Now there's 2 ways to do this. I'm only going to show you the one way right now because I want you to use the distributive property. And I want you to understand that if a number is outside of a parentheses, see how it's outside, and it's multiplied to that set of parentheses, then we use the distributive property. Now, a lot of students have a really hard problem with the 8 being here. I want you to understand that this is exactly the same thing. And I have told students you can actually move this to the front if you want to, if it'll make it easier. But if you have a number crammed up next, it's multiply. If you have a number crammed up next to a set of parentheses, then that means you have to take this 8 times each piece in the parentheses, just like you would do here. The 8 times every piece in here. This is called the distributive property because you have one number that is being distributed over everything that's in the parentheses. So the first thing, of course, we're going to have our line down through the equal sign, and we're going to circle our x. And we found out that these are locked inside a set, and you can't come in and say -5. You can't do that until you unlock it by using the distributive property here.
So me is always first?
Depends on how it says. But the way it's worded, it says, add 5 to me. That means I really was here first, and then I'm going to add 5. Do you see? It's
That's
just...
what I was kind of like, me was like after the number, and I was like, well,
Yes.
does the number come first or does the x come first?
It's almost like a switch phrase, but I didn't
phrase,
want to teach it that way
Okay.
because it isn't always. It's more of a this makes sense. Because if I'm going to add something to me, I had to be there first
Yeah.
before I could add something on, right?
Yeah.
So just something to get used to, and it's a good question, Irene.
Yeah, that was kind of confusing me.
Yes.
How to start the problem.
And you know, it helps me because it's been a while since I was back in your position. So some of the things might look weird, and you have to tell me what looks weird. Thank you.
Thank you.
All right. So we found out that we need to distribute this 8 over everything that is inside the set. So if I take 8 times x, and remember, this is 1x. There's an invisible 1 here. So you're taking 8 times 1 is 8, and the x is part of the deal. 8 times 1x is 8x, plus 8 times 5, because it's also in the parentheses. So 8 times 5 is 40. And then we write down the rest of the problem. Now notice that you did not take 8 times 72. And the reason you didn't is it's not in the parentheses. So we only take 8 times the stuff that's in the parentheses and then stop. Okay? So here's our problem now. And again, you're saying, I think I understand this one. So we're going to do what we always do and make sure there's a line down through the equal sign and circle our x. Focusing on this side because that's where the circle is. Then we say we got to get rid of the 8 and the 40, but we found out it's important which one goes first. We remember our silly story about the best friend and the straggler, and so we get rid of the straggler first. See, they're not in any kind of set, and so our rules come back and apply, okay? So since it's plus 40 on our straggler, we're going to minus 40. And before we do anything, we have to minus 40 over here. So we make sure we don't forget to balance the equation. Now, coming back to this side, we see that the numbers are the same, but the signs are different. And when you add those together, you get 0. They're called a 0 pair or additive inverse. We're going to add straight down now. So we're left with an 8x equals, again, this is 72 plus a negative 40 because we're adding. It looks like minus, and it's okay to minus. So we have 32. But later on, if you take your calculator and put 72 plus a negative 40, you will get the same thing as if you divide or if you subtracted, okay? All right, so be very careful there. And then make sure there's a line down through the equal sign. We circled the variable and we see that it's not by itself yet. So you have to go one more step. We need to get rid of the 8 now. It's multiplied. It's an understood multiply because it's crammed together. And if it's multiplied, the only way to undo that is to divide. So we're going to divide by 8. We have to balance the equation. We found out that 8 divided by 8 is not 0, so don't zero that out. 8 divided by 8 is 1. So now we have just a 1x equals 32 divided by 8 is 4. And this is not wrong, but this won't be written on your test. They will leave the 1 invisible. So your answer to this problem would be x equals 4. Rebecca, did that help?
Thank you.
Good. Mary, that was yours, wasn't it? I'm sorry. Yes, did it help?
You're doing the pendulum. Did you get cold yet? Okay.
Is it getting cold?
It's getting cold.
Go to the thermostat. All you have to do is hit warmer a couple of times. Whoever wants to. There's a button that says warmer. Just hit it a couple of times. Thank you for telling.
I was actually thinking about bringing a sweater in this morning.
No, I don't want to freeze you out. I've got a fan. So
Yeah.
what to say? Go ahead to 72. It'll be okay. Yeah, that'll be good. Okay, let me know if it doesn't get warm enough. Okay. Let's get a pile of blankets over in the corner, I think.
Right? I was thinking about bringing a blanket in.
You can. I'm not allergic to that. All right, any more on the 3 sheets that we tried yesterday?
Let's try number 2
On
on sheet 3.
number 2 on sheet 3.
It says this one third of me.
Oh, okay. What is of? Go back and look at your vocabulary.
Of is
What does of mean? It was that list that we did on Friday.
of is multiply.
What does of mean? Yes,
Oh,
Naomi,
multiply,
tell me.
yes. Multiply.
Multiply, you found it too? Yes. Okay, so I'm going to read it for the recording. If you add 3 to 1/3 of me, you get 10. Okay, so Irene, again, 1/3 of me is going to be established before you add something to it. So we're going to write the 1/3. We know that it's written like this, 1/3, and we found out that of in multiply means times, okay? 1/3 of me, okay? 1/3 of me, and then we're adding 3.
Oh.
We're adding 3. It says if you add 3 to 1/3 of me,
Oh,
you get 10, right?
yes.
Okay. Now the first, well, of course I would do this, and I would circle this. One thing that will help you, if you see a number of, or a number times the variable, let's write it like you usually see it. The multiply, you can cram these together, okay? So you have 1/3 x plus 3 equals 10. We didn't do any mathematics there. We simply said 1/3 times x. Let's not have it so spread out. You can cram these together and it means times. Are you guys okay with this? All right. Now, when we circle our x, we find out that we're going to need to deal with this side of the equal sign. And so we have 2 different things we're going to have to get rid of, the 1/3 and the 3. The 1/3 is crammed together, so it's multiply. Which one do we need to get rid of first? The 3, because it's a straggler, this is best friend. So we get rid of a plus 3 by doing a minus 3. We're going to balance the equation first before we do anything. Now we can start to do our math. The numbers are the same, the signs are opposite. They are additive inverses, a 0 pair, they're gone. Add straight down and we have a 1/3 x equals 7. Okay, this one I am going to tell you 2 different ways because it might help you. 1/3 x, if I have 1/3 x, any kind of fraction x. Let me see if it'll show. Okay. It's the same, we said it's multiply, right? So I have 1/3 times x. Well, if I want to multiply this, I'm going to make both of them be fractions. So 1/3 x is actually the same as x over 3. Y'all see it because it's 1. 1x over 3. Do y'all see? So if you're going to write a fraction with an x, put the x on top if you want.
Is that kind of like the switch base?
No, it's just a multiply. Like if you have, let's do this, 2/5 x. If they say 2/5 x. And you don't want to deal, well, I'm going to show you how to deal with this one. But this is the very same as We know this is multiply because they're crammed together. We know the x can be over 1. So multiply the top together, you have 2x over 5. Do you see these? These are the same thing. 2/5 x, and if we actually multiply it out, we have 2/5 x. The x will go on top most of the time. Okay? We're going to deal with it as 1/3 x right now and show you what to do with it. But you can also know that it looks like this for later reference. I'll remind you. Are we good?
Yes.
Okay.
Thank you.
So what we're going to do is deal with it the way it's written right now. So if I want the x by itself, I circle the x. That means that I have to get rid of the 1/3. Okay? Now, getting rid of a fraction is like, how do I do that? Well,
Divide it.
we can divide it, but how much do you want to take 1/3 divided by 1/3?
I think you make it a fraction, then
You just do you put the 3 on top and put the 1 on the bottom.
When we're trying to get rid of a fraction, we will multiply by its reciprocal. Reciprocal means that it's flipped.
That's what I was saying.
I really did think that you were, but I would hear pieces and then I'd hear my fan. Okay, so I know all of you guys are pretty smart. This is when you flip your fraction. A reciprocal means flip it, okay? And if you take a fraction times its reciprocal, you'll always get 1, but let's show you why. So we decided we want to get rid of a times 1/3. We're going to times by the reciprocal. So the reciprocal of this would be 3 over 1, yes? But before we go any further, we have to balance the equation. So I can do 3 over 1, or I can do 3 here. It means the same thing, yes? Okay, so now we're ready to try to figure this out. Notice that I have a top, a numerator, and a denominator that can be divided by the same thing. So I cancel this and make it a 1, because it'll divide by 3. This will divide by 3, and I've got a 1. So I've got 1 times 1 on top, 1 times 1 on the bottom, and an x. Well, 1 over 1 is 1, and we found out that we don't write the 1. Is that true?
Yes.
So we went through a bunch of stuff, but now you see where we come out with the x by itself equals, and all I have to do is multiply here, 21. Are we good? Okay. So if we did this one over here, where I had 2/5 x, and you wanted to get rid of the 2/5, you would multiply by 5 over 2. You just flip it. So the 5's cancel and the 2's cancel. Yes? Okay. This happens when we have fractions and you don't know what to do with it, and you know I'm going to have to divide by a fraction, and yuck. So actually dividing by a fraction is the same, absolutely the same as multiplying by its reciprocal. Okay, so it's the same thing. And I've only said that one once, so don't worry about it. There's 41 more times. Okay, any others on our papers from yesterday? The ones for today that I'm going to do the examples on the board, you won't learn anything new, I don't think. We're going to practice the vocabulary that we learned yesterday and start to put these together.
So you want to do one more?
Yes, I will. I'll do whatever you need.
How about sheet 2, number 5? Anybody did 5?
Sheet 2, number 5.
Yeah, it was, I saw yesterday.
Sheet number 2,
Yeah.
number,
Oh, it was also one that on sheet 2. We'll go ahead and do the other one.
okay.
I'm just saying.
Sheet 2, number 5. Oh, yeah, there's some wording here that we need to straighten out. I'll read it for the recording. If you add 7 to 1/4 of me, you get 12. So we know that the me has to be established first before I can add something to it. If you add 1/4, how do I write 1/4?
Yeah.
Pardon?
125?
You would think so,
You put decimal.
but 1/4 is the same as 1/4.
Oh.
So you might want to put that on your vocabulary page so you will remember that. 1/4 is 1/4. It's a quarter of a dollar, so it's 1/4 of me. I'm letting you put it in vocabulary and I'll get there. 1/4 is a fourth. Okay, so I have 1/4 of me, and it says if you add 7 to 1/4 of me, so I'm going to add 7, you get 13. Line down through the equal sign, of course. Circle the variable. That way we know, keep the sides separate. When I look at the side with the variable, I want it by itself, so I know I'm going to have to get rid of a 1/4 and a +7. Which one do I get rid of first?
7.
7. Okay, he's kind of the straggler, best friend. So it's a +7, I have to minus 7. And minus 7 to balance the equation. When I do, I have same numbers, different opposite signs, and they create a 0 pair or additive inverse, and then we add straight down. 1/4 x equals 6. And then, because we're not afraid of extra work, we go ahead and circle our variable again. That tells us, don't touch the variable, but I have to get rid of the extra stuff, and that happens to be a 1/4. Now the 1/4 is crammed next here, and that would tell you I've got to divide by 1/4. Yes.
It's not 13, it's 12.
Is it 12 on the problem?
Yes.
Oh, yes.
I guess I'm just making up my own stuff. Yes, ma'am. Thank you so much.
Oh, yeah.
Making up my own problems. Where did I get 13? 12.
I was like, wait, what?
Wait.
Thank you, thank you.
Cuando hice la prueba,
Vanessa, in high school, I would make mistakes like this, and if somebody caught my mistake and corrected me, they get extra points. So you get 100 bonus points today, Vanessa. I always want you to do that. Don't ever be afraid of me. Okay, so now we're going to look at this, and we want the x by itself, so we know we have to get rid of the 1/4. Now what we've done in the past, if it's times, I'm going to divide by 1/4, but we found out dividing by fractions is kind of a pain. So when we're dealing with fractions, let's just multiply by the reciprocal. Just makes it easier. And whatever I do to this side, I have to do to this side. So I see a top and a bottom, numerator and denominator that will divide by the same thing. Gives me 1. 1 times 1, 1 times 1, I have 1x equals 20. Better? Getting better and better? Now, did you say there was one more, Rachel?
Yeah, it's number 1
On
on page sheet 2.
sheet 2, number 1.
Oh, we did that together. Oh wait, maybe. Yeah, I had a star on it from yesterday.
Yeah, it could have been
Oh,
one,
yeah,
we
the
were
other
working
day.
together,
Yeah.
Yeah,
and I said, just wait, Rachel, and we'll do it
yeah,
tomorrow. Okay, that's fine. Sheet 2, number 1.
yeah.
Okay. The problem says, if you add 3 to me and divide me by 4, you get 4. So I'm going to have me, and I'm going to add 3 to me. So far, so good? And then it says, and divide me by 4. You get 4. Now this means I'm not just taking x divided by 4 or 3 divided by 4, but I'm taking the entire piece divided by 4. And that's why I use the parentheses again. Makes it a set. Draw a line down through the equal sign, circle. We would be very, very tempted to minus 3. But if you try to go up there and minus 3, this is going to be a mess. And besides, it's against the rules. You can't go into this locked building and just take a piece out. Can't do it. So we have to unlock it. And of course, the cool thing is to unlock it is what we don't like anyway. So let's get rid of it. How is the 4 connected to the problem?
Divide.
By divide. And so in order to get rid of it, what do we have to do? We have to multiply by 4. If this is divided by 4, we have to multiply by 4, and we put it over 1 because we're dealing with a fraction. Before we do anything, we have to balance the equation. You can do this if you want. We can balance the equation and put the 4 over here. Okay. Always balance the equation before you get started with your math. Okay, we have a numerator and a denominator that divide by the same thing. So we have 1 times x. This is the distributive property. And 1 times 3 is 3. This canceled out to 1. So on the bottom is an invisible 1 equals 16. From here, it gets much easier. And all we have to do is subtract a 3 because it's a plus 3. So we minus 3. We balance the equation and see what's left. We have x equals 13. Yeah? How do you feel?
So I did get that right yesterday.
Yes, but I wanted to explain it to the whole class, and that's why I had you start it.
Okay.
Okay? All right. How are we now? Any more? All right. Let me go to the next set. And actually, I don't think there's any new vocabulary words. We're just going to start to put those together in expressions and equations. We'll start easy. I think you can already do these because we were doing them in those problems yesterday. This says, okay, and they just want us to put this into mathematics. It says 2/9 of h.
Where is that at?
You don't have it yet.
Oh,
So is it 2 divided by 9?
It actually is. That means this is a fraction. Yes. Yes. And so we're going to take this part of the expression and we're going to write 2 9s, right?
Yes.
What does of mean?
Time.
Times. And then we're going to write the h. And we found out that we can, if it's times, we can cram it together and say 2 9ths h. Or remember that the variable goes on top, so you actually could do this later. This is optional. You would have probably written it like this and this if you had the paper to work with. Easy enough? Let me find, oh, there are a couple of words, okay? If it says the square, or they'll just say squared or something to do with square. That means the exponent 2 squared. Okay, so the vocabulary might say the square of 5. That means 5 squared. The little exponent up here, that's what these words mean. And the same thing is the cube of, or cubed means the exponent 3.
The cube of,
Or you usually, they say this x cubed, x squared, x cubed, x squared. Then when you get to a 4 and a 5, they just say x to the 4th, x to the 5th. But these use words, squared, cubed. Okay?
so on these, we're not gonna,
Wait.
You don't solve
we
them,
don't solve them, we just write down what it's saying.
right? Because it's only an expression, an equation. When it has the equal sign, that's when you'll start to solve it. Okay, let's try this one. Now this one you would have figured out on your own, but reduced, what do you think that means?
Subtraction.
Subtraction. Okay, and increase. These are some more words that I figured you probably would know. Okay, decrease. It's minus. Okay, those type of things.
What's that last word you just wrote?
Decrease. D-E-C-R-E-A-S-E. Decrease. So, let's say G
Is that a 1 up there?
It is a 1. This is a 1.
Reduce you put?
G reduced by 1.
Might be little like.
Do what? It's got some reflection, does it? Okay. So, you know you're going to write down a G, right? That's the variable. Reduced. What does reduced mean?
Minus.
These are expressions because they don't have an equal sign. That's why we're not solving these.
I'm loving these already.
I didn't hear that. Would you?
So I'm loving this already. No solving.
Well, just don't get too excited. Look at this. I promise we won't do them all today.
What is the last word it says?
This
Uh-huh.
decrease, D-E-C-R-E-A-S-E, decrease,
And what is that? Right?
minus,
So reduced and decreased means the same?
yes. A lot of different words for the same thing. Okay, let's do this one. Y'all will have to think about it, but you'll know it. One.
So it's 1 divided by 2.
Okay. She did this.
So it's going to be exponent
Of,
x.
Times.
how do you write this?
Okay.
The exponent?
You would write K, and this is the cube
3.
of K.
That's what I was thinking.
Good, good. 1/2 of is the times the cube of K, cube of K. And you could
put the 3 up there next to the K.
When it has the cube of.
cubed. These are exponents, we'll work with,
Gotcha. Okay.
it belongs with it because it's cubing K. And what this means right here is K times K times K. It says cubed means I'm taking this times itself 3 times.
So like if k was 5, it would have been 5 times 5 times 5.
Exactly. Exactly.
And I know we're not working this out, but how do we figure out what K is in this problem?
You wouldn't be able to until you had 27 over here.
Okay.
Then you would multiply by 2,
Okay.
and then you don't know this one yet, but when that was gone, then you would take the cubed root, which we haven't even touched yet.
See, that's getting closer
It's
to
getting
algebra.
harder and harder. Oh. Let's just stick to basics.
That's why I don't take you too far at a time. Because I know what's in the future. Just work with me now. Just work with me now. All right, let's see if there's anything else.
My brain's telling me, what am I doing?
Okay, this one.
I'm waking it up.
And my brain said, "What did you ask?"
Addition,
Add,
x
Yes.
to 4.
add x to 4.
But what has to already be there?
The x.
It says add this much to the 4.
Okay, so whatever x is.
So the 4 has to be there.
Oh, this is a switch phrase.
Yeah.
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 Kind of.
Yeah. Yeah. Add x to the 4, so that means the 4 already had to be there in order to add something to it. You see it? It's hard for me to explain why that might be a switch phrase, but if you want to think about it that way, that's good. We have to have the 4 before we can add anything to it. Are we better?
We're getting there. We're getting there.
Maybe I'm starting to get it now.
Getting there?
Yeah. Yep.
Well, the one thing that's cool is the papers I give you have the answers on the back.
Okay.
Ah, how about this one?
Oh, So raise y.
That the fourth power would be like an exponent kind of.
Like the exponent, yes!
Ah.
Okay, so we know we have y, and it said raised to the fourth power. Well, we said we have squared and we have cubed, but after that, we just say to the fourth power, to the fifth power, to the sixth power. So that is,
Oh, so yeah,
That's it.
That's what I was thinking.
it's y raised to the fourth power.
So much wording for two things.
That's how I feel
That's
when I
it.
buy groceries, and I have one sack of groceries and it costs me $75, makes me really,
No.
yeah.
When you're doing the recipe, wait, I'm writing it down.
Okay,
Wait, I'm writing it down.
all right. Now on these, when you get them, be sure and work together and look at the answers on the back. Some people think that's cheating. It's not. Try it. Look at the answer on the back. If you're not getting it, compare it and find out why. Because I'm not going to be able to go over everything here,
All right.
but the answers will help you. And I'll be here. Okay. So now, those were expressions. Now let's do some equations. I promise not to talk much longer, okay? It was kind of long today. Whoa, here's another word. They use this. I haven't seen this very much. They use thrice. Thrice. You know, twice is 2 times. So thrice is 3 times. They're going to use this on your worksheet. I don't see it much, but you need to know what it is. Okay, here we go.
What's up there? One. So 4 times.
4 times the square of y minus 3/4 is 2.
4 times. So
So as soon as you write it down, let's just work it together, okay?
So would it be 4x?
Okay, you're getting close. 4 times, right?
Oh,
4 times. Now we need to write the square of y. How do we write that?
Y
and the
and then the
Squared, right?
minus 3/4. So a fraction
Uh-huh.
equals 2.
Good. Is means equals 2. Now it looks like a really ugly problem, but we don't have to solve them. All they want you to do is write them.
Oh,
Okay.
like the expression.
Like turn them into a problem.
Turn it into a problem, a mathematical problem. Yes. Translate is what they call this.
Because that's on one of the tests on the
Yeah.
computer.
There's
And I couldn't figure that out, and now I get it.
See, every day, there's just one more problem that you can work on the GED test. You get closer and closer and closer and closer. Okay, let's do, I'm deciding how many of these to give you. Oh, good. I want you to have this page. I'll give you 3 pages today. Let me take a couple off of here and then I'll stop.
And they do have questions like that, test how to write, write the problems down or the expression.
I just guessed them.
And now you don't have to. Right?
Yeah.
Okay. I saw one here that I really want to do. Okay. See, they start to get longer, but this is how we move you into word problems so you're not as scared of word problems.
Is that what decrease?
It is,
Decrease.
this is the letter Z.
Oh, Z.
I put 2.
Me too.
Sometimes instructors do this. I never got in the habit, but they do like this, so you know that it's a Z variable. I'll try to remember to do that.
So product means
Multiplication.
Yes.
so you're gonna multiply 4.
4 multiply.
Remember, if you, this is one of those 4 words that if you see it, what do you write down?
Because product is times 2, right? Because you put,
And then.
Now, product is just multiply. But remember those 4 words I put down at the very beginning, and I said, if you see one of these words, you automatically put parentheses.
Oh.
And this means times, so you put a times in the middle. Because every single time they say the product of, or the sum of, or whatever they say,
4.
they're going to tell you in the very next words, they're going to tell you what to put here and here. So we did product of, okay? That's what this is.
So you put 4 and Z.
4 and Z. See? That takes care of that. Because these words will always be followed by something and something. So the and is where you decide it's this one and this one. Okay? Now it says decreased by. What does decreased mean?
Subtract.
Okay, decreased by
14.
14
Multiply it by 6.
gives is going to be the same as equal or equivalent to or any of those. Aren't you glad right now you're not solving it?
Would we solve this with PEMDAS or no?
With what?
The PEMDAS?
Yes.
Okay.
So you can actually try it if you'd like. You want to do it? Let's do it, Naomi. Okay. PEMDAS. We're going to do this side first. Okay, so what do I do first?
Parentheses.
Parentheses. So what do I have?
4
4
times
times
1.
I have 4Z. 4Z, okay?
Minus
And then I write the rest of the problem down, okay? Now here, according to PEMDAS, what do I do next?
14 times 6.
14 times 6. So that would be,
Uh,
84.
84.
equals. Yes?
Yes.
Okay. Now you're at the point, Naomi, where you would do the subtraction if you knew what this was. But now is when you stop and change gears and you solve the equation. This stuff you guys don't have to do yet. She just said, would I use PEMDAS to do this? So you guys can go ahead and copy it. It's not something you have to do today, okay? So here was where you would switch gears and make sure the line's down through the equal sign and,
Circle your variable.
okay, so what would you do next?
You're gonna plus 84 on both
Plus
sides.
84.
That one zeroes out. 4Z equals
See, that's
1, 2. And then you're gonna divide by 4.
be a 1.
Z equals
I think it's going to come out a fraction, probably. If I divided 4 into there,
1, 2,
2,
4.
it'd have to,
25.5.
what is it?
25.5.
Okay. This is all you guys are going to be doing today. You're just going to be translating. But Naomi was asking, and what you saw here is we use PEMDAS that we already learned. And when we get down here, we solve equations like we've already learned. Now we can start to put things together. Do you see, Naomi? So now you're excited because you got out of bed and said, what am I going to learn today? Yes. I love that. Okay. So you ready to hit the books? Yeah. You okay, Vanessa? You look sleepy today. Really sleepy. Yes.
I was so tired yesterday. My daughter kept me up till 2.
Oh, no.
She went to sleep by 3.
Okay, I'm going to stop this recording and we're going to make sure that maybe it recorded today.